I don't know, space thermometer problem, and it's actually kind of tough. So I think I'm going to make a little video to help you folks out. I'm going to do an example problem real quick, and the example problem is straight out of the book. Let's do that one first. If I were to compare a um, thermometers together, and I were to compare a Fahrenheit thermometer with a Celsius thermometer together, I would notice that the well, I would basically take freezing water and I would put both thermometers in there, and I would notice, hey, this thermometer says 32 degrees Fahrenheit, and this thermometer says 0 degrees Fahrenheit. You good?
Yeah.
All right. And then I take both of these thermometers and I put them in my mouth. And since I'm healthy relatively, this thermometer reads 98, which means I don't have a fever. I'm about average temperature. The other thermometer, what will the centigrade thermometer read? That's my question to you. And so the way we can figure that out is we said, all right, well, we know the equation Fahrenheit is equal to 9 fifths times C plus 32. So if I told you that my Fahrenheit was 98, then you can tell me what C is by simply solving for C. You subtract 32 from both sides. Um, was it exactly 98 or was it a different number? Oh, they said 98.6. I'm sorry. All right, so you subtract 32 from both sides, you end up getting 66.6 equals 9 fifths C, and then you multiply by 5 and you divide by 9 to get rid of that, and you end up getting C is equal to 37. Was that correct?
Yes.
And you understand how we got that? All right. So, this is 37. All right. Here's the thing. Um, the I guess what I'm trying to get you guys to understand, and this is why this is a really hard problem and it's at the end, is this 9 fifths. What that acts as is kind of a ratio between the scales. It's kind of converting the one scale to another scale as far as like the size of the things. I suspect the best way to kind of describe that um, would be the difference between inches and centimeters. Centimeters are almost an inch is almost 3 times the length of a centimeter. It's actually 2.5 times a centimeter. In fact, I can tell you exactly. It's 2.54 centimeters is exactly 1 inch. So those lengths of the scale is bigger. Is different. Now, if you, which one would you say is a smaller measurement? If I go up by 1 degree Fahrenheit, did I go up a little bit of temperature? And then if I go up by 1 degree Celsius, which one did I make a smaller jump on? Does that make sense?
Yeah.
And I'll give you a hint. I think that, um, let's see, I think that, okay, here's your hint. If you go up, and if you start at freezing water and you put this both in your mouth, you'll only go up 37 degrees Celsius, but you'll go up 66 degrees Fahrenheit. So which one has a smaller measurement or smaller size? It's actually the Fahrenheit, right? Because you've got more tick marks. You've got 66 tick marks in between here and here, versus you only have 37 tick marks in between here. Right? Does that make sense? So that's the reason for that ratio. The ratio is kind of adjusting for the size of these difference in measurements. Now this 32, where does this 32 come from? What do you think? In the original equation.
From this Fahrenheit.
I kind of call that the offset almost. It's almost like um, it's taking into account that 0 for Celsius doesn't mean 0 for Fahrenheit. It's almost like you know what this equation reminds me very closely of. It reminds me of y equals mx plus b. Have you seen that equation before?
Yes.
Y equals mx plus b is the equation of a line. M being the slope, right?
Yeah.
And b being the starting point. In this case, the Fahrenheit doesn't start at 0, it starts at 32. Does that make sense?
Yes.
All right, so now let's go. All I did was I talked to you about this problem, and this is a separate problem completely. Now let's go to the problem at hand. And this one was kind of weird. And this is where I really wanted you guys to think about this stuff. And this is what makes chemistry really interesting and tough. All right, so we have two new thermometers. One is still our centigrade thermometer, and let's say negative 10 degrees centigrade and 130 degrees centigrade. And then over here, we have some kind of new scale, like an alien thermometer that has 0 degrees X. I don't know. Which stands for, I don't know, what's her name?
Quinn.
Okay, which stands for Quinn. We have 0 quins. You know, we measure this and it's 0 quins, and then this one's 50 quins.
Which for some reason we denote with an X or something like that.
We could use a Q,
Yeah.
but I mean, I don't know. Okay. So, what we need to do is we need to come up with an equation that maps one to another. Does that make sense?
Yes.
Now, here's the thing: is what I want to know is where did we get the 9/5? Well, I think what we can say is
I wonder what 66 divided by 37 is.
try to write that in your calculator. What's 66 divided by 37?
1.783.
1.783. All right. What is 9 divided by 5? Tell me the number for that.
1.8.
1.8. Hey, those are
Just
just
about the same number, right?
Yes.
In fact,
what is 66.6 divided by 37? I want to know what that is.
47.
yeah, 37.
1.8.
1.8. Oh, okay.
So I think that we can figure out a way to find our ratio, right? We just take this number and divide it by this number. Well, going back to here, what's this number right here? The difference between here and here.
Look at the picture over here.
Can you see it? 140. Perfect.
And the distance from here to here?
50.
50. Okay.
So what is our slope, essentially? It would be 140 divided by 50.
140 divided by 50.
Right, it's that ratio that we're talking about. It's taking into account the difference in scales.
Mm-hmm.
2.8. Can I convert that to a fraction with this thing? Oh, it's 14 over 5. Yeah. Okay. So that's
2.8. Actually, you know what? I can just
cross out these two tens and I'll go 14 over 5. 140 divided by 50, you just divide top and bottom by 10, 14 over 5. Also known as 2.8, but let's not go there. Alright, because we want a fraction. We want a nice, not a decimal number, we want a nice perfect number. Alright, so that's our ratio. Okay? So, what about our starting point?
where is this?
Thing, the 0 for this is where here.
So, like, what would be the equation then?
Well, what I'm saying is,
Where did we get? Alright, there's a number that's supposed to go here, and where did we get that number? Look at the equation for Fahrenheit. That number's 32. Where did we get that number?
you don't know.
You told me where we got it earlier. Where did we get this 32 from? I told you where it came from.
Fahrenheit, I think.
It came
From the starting point not being the same,
Oh, yeah.
right? So we would add
We did.
plus 32 over here. So
Let's see. Oh wait, this is supposed to be a C.
C is equal to this times x. And then this would be minus, so I'm going to write this down. C is equal to 14 over 5 x minus
10. Because this and this.
is not starting at the same place. Does that make sense?
Yes.
So
Based off of this thing, I came up with an equation.
for my new thermometer, the Quinn thermometer, which is a pretty cool name, by the way. All right. So
If they're saying
the outside temperature is 22 degrees Celsius. What temperature is it in Quinn units? And you simply put 22 for C, and then you solve for x.
so, that would be add 10 to both sides, and then I
I
would.
would have 32 equals 14 over 5x, and then multiply by 5, divide by 14, and
Then
then
what do you get? What's
5 times 32 divided by
14.
11.42.
11.42?
Awesome. Now, I'll be honest with you.
I think that the original problem.
Told us it was 22.0 degrees Celsius, and you don't need to necessarily go here, but in chemistry we like to say, well, how many significant figures are in this number? There's 3 significant figures, so when we pull all of this stuff through, we want to say that there's exactly at least 3 significant figures here. So we don't want to say 11.42, we would rather just say 11.4. Does that make sense?
Yes.
Then the second question is asking, this one over. And then the second question is asking, convert 58 degrees X into Fahrenheit. Okay, fine. If I have, my equation was C is equal to, I think it was 14 over 5, yeah. 14 over 5x minus 32, and they said convert what? Convert 58 degrees. Alright, so what I'm going to do is I'm going to plug 58 in here.
And then solve for C.
C. Is that my answer? Whatever that comes out to be?
We need Fahrenheit.
I mean Fahrenheit. So after that, I take that whatever C I get, I'm going to get C equals, I don't know, 572 or something like that. That's not the answer. I just made it up off the top of my head. I can't multiply 14 times 58 divided by 5 and minus 32 in my head. So I'm just making up some number, but once you get that number, then you plug it into a different equation to convert it to Fahrenheit. And I think that that's it. This was a tough problem, and it really forced you to understand how we built these equations. Maybe it wasn't fair that I didn't cover this with you before, but I wanted to see kind of where you went with this. All right, anyway, that should help.